starting.
So, what I was saying about safety. Safety. Okay? What I was saying about safety is that don't do what? Don't scatter the cells anywhere so that you can manage them. If you are arranging your cells, just the way we do this arrangement, okay? Make sure that you can see here all the positive sides are one place. All the negative sides are in one place. If you want to package this battery for someone now, the safest way is for you to keep it like this. Shey you get? Because all of these are what? Are negative. There is no how that this negative like this, you leave it there. Even if something falls on this thing now, it dey hard say you join here. Even if you join here to this place, there is still no problem. Na parallel am. Shey you get? But when you go do, assuming say you do like this, you dey like this. Some of like this one now wey don dey pin now, there is tendency say issue fit dey. So, but when you arrange yourselves like this, you are very okay. Even if you want to arrange them like this, you find something like carton and put it there. You can still put other ones on top. So that's what you call like insulation. You have insulated it. Don't go and use iron and put here. If you put iron, nah, you are on your own. That is not insulation. So now, if you are charging, just what I don't hope it's capturing this place that I am. Is it capturing me?
No, it's okay.
Okay. So if you want to charge your cells, use specified chargers. Like Litokala now is what? Litokala now is very good. They are programmed to stop charging the cell at what? 4.2 volts under this thing. At 4.2 volts. Once it gets to 4.2 volts, it will do what? It will stop charging it. Once you get to 4.2 volts, it will stop charging it. Now, there are different ways you can charge your cells. Okay, there are different ways. You can use Litokala or you can use TP board. Those things you are using here, the name is what? Is TP board. If that is not working, just leave it. The name is TP board. Let me show you an example. So this is a TP4056 watt charging board. From the inputs here, you can see this look like your phone charging port, abi?
Yeah.
And you know your phone, you input what? 5 volts. Abi, you don't know the voltage of your phone charger. Every phone charger at least will be what? 5 volts. Why is it 5 volts? Because the full voltage of this cell, even your phone is made up of this type of cell. You know, each one is called a cell. But you know, they made it in a different form. It's pouch cell. That's what they call that. That flat one that you see in power bank is called what? Pouch cell. So when somebody asks you, do you have 3.7 volts pouch cell? No, that is not talking about this one, but that flat one. That flat one and this one, they are still the same characteristics in the sense that once that one is 4.2, that is the full voltage. Once it's 2.5, that is the low voltage. Okay, so now what have they done here? You can input 5 volts, but output here is what? 4.2. That's why you see that we use it in charging cells. 4.2. And now the charging, okay, now when they say charging current, now this one is 1 amp. That is the charging current. You know, that day I discussed, say current will just tell you how much power is flowing through something. So this one now is 1 amp. And since the voltage is what? 5 volts, abi? The current is 1 amp. If you multiply 5 by 1, you have 5, abi? So voltage times current is watts. So it means that this is the 5 watt charging board. It's 5 watts. That is 5 volts, 1 amp board. 5 times 1 is 5. It's a 5 watts charging board. Let's assume you have another one that is 5 volts, 2 amps. The charging power will now be what? 10 watts. 10 watts. Power is the SI unit is what? Watts. That's what they measure it with. So that is it about using this one for charging the cells. If you use this one, there is no how the cell will overcharge because they have programmed it already. But there are some people now, they will just say, okay, this cell, okay, and now why do we use 5 volts? You can use 5 volts or even 4.2, for example. You know, you want the battery to be fully charged. You need, okay, now in between a rich man and a poor man, who can give the other person something? Rich man, right? So you have 5 volts and you have the battery that takes 4.2 volts to be full. Shebi 5 volts can give 4.2 or 3.7 volts cell. So 5 volts can give the other one that is low. 4.2 cannot give 5 volts. Right? So that is the way you see the same thing. So because you have 5 volts that is not at 4.2, 5 volts is like is pushing something to 4.2. 4.2 will now absorb it. But as it's pushing, what if 4.2 come full now? You no get anything to block that pushing. Or let's say that you say you wan drink water now, you just dey pour water for your mouth, your belle full. You know wetin go happen, and there is no way you go fit say you don do. Your belle you go burst now. So that is the same thing that happens to this cell. If it's taking charge and it gets to the point that it's full and there is nothing to stop that charge from coming, it will burst. Even in your water tank, the way they design it, no be all this one wey be say water tank go full, water go dey throw away. E get something wey dey call is it floating valve or something wey be say e dey like ball, dey put am inside tank. Once if that thing now dey down na because water level dey low. This is your tank, and then this is that thing dey like ball like this. You know say as water dey come out, this thing now na here pipe take enter the tank. Okay, so as water dey enter this thing and water dey low, let's say the water level is here, you know this thing now e can get to this point sef, e fit dey like this. But as the water is rising, this thing too will be rising. Once water gets to this place, this will now raise up and it will block the water coming in. So water no go dey throw away for tank. So I don't know why they are not doing it here, but we learned this in school. So this will now go. So you see the same thing with that cell. Once it's full, there should be BMS to do what? To stop charging so that it will not overcharge. And one thing I've learned is that most times if you are using 5 volts to charge this type of cell, 5 volts, it will hardly burst or explode. Maybe if someone has experienced it, he will tell me. If you are using 5 volts to charge this, because so many people that do put battery in MP3 players, once the charging port is bad, some people will just bring out wire from the battery outside. They will be using 5 volts to charge it. What will happen most times is that this cell now, once you charge it to a certain voltage, once it's full, the thing will now get hot. Once it gets hot, that thing they call CID, that inside of this, inside of it, that CID will just shoot up. You will just see that battery is no longer bringing voltage. You don't read anything. You will see any voltage here. But if you don't enter 12 volts battery, okay, you are on your own. If you don't enter 12 volt battery, you are on your own, because you know say 12 volts plenty, the voltage plenty. If you no do am well, you go put high voltage or you no go put BMS, it will blow your battery. You will just hear boom, and that one now na fire na you go see. Na fire na you go see. So you go know say no be only lighter na im dey bring fire, no be only matches. Cell dey wey dey bring fire also. So you should be very very well safety conscious before you charge your battery. If what you have is not 4.2, make sure you find a board to step it down to 4.2. Like those people that are doing MP3 repairs, you can decide to put BMS in that battery now, so that the wire, even though you are charging direct, it will pass through BMS before it gets to the cell. That way your battery will be safe. There's another way of charging this cell. You can use a power bank board. You know, power bank board, they use it for this lithium ion. No? Yes. This 3.6. Just to connect the board to the cell. You don't do power bank. There's nothing hard in power bank. If you are doing power bank, just have your power bank board and the cells. You can join the cells in parallel. I will still do that parallel connection. You join the cells in parallel, meaning positive to positive, negative to negative. You join them together. Why you join them together like that is for, instead of only one cell, you now have so many of them. Their power will now add up. Their current will now add up. But the voltage will remain the same, because those power bank board, most of them are only one cell in parallel, 4.2 now they maintain. So power bank board, there is what they call buck boost. If you see buck, you can see buck, you can see boost. What is the meaning of boost? To boost something. What is the meaning of boost? To increase. Even the name boost, to boost something. Then you hear buck. To buck is not bulk.
I say bulk.
You know, there is bulk, there is bulk. Bulk is many things, so many number of things, whatever bulk. But this is bulk. Bulk is like this. That is, you open like this, you call bulk line. You don't reduce it. So if you see bulk now, sometimes they say bulk converter, meaning that one they use that reduce voltage. They reduce voltage. In bulk converter now, input voltage now is always higher than the output voltage, because you are bulking something, meaning that let's say you put 5 volts here, the output you should not expect 5 volts, you should expect less than 5 volts. Then power bank board. Alright, check who they call, answer that.
My number.
Hello. So,
Hello.
this is an example of what? A power bank board. This is an example of a power bank board. This power bank board is a buck and boost board. Why do we call it? We call it what? Buck and boost board. So this power bank board, let's say you need buck boost or buck and boost board. This power bank board is one of it. Why? It's because with this board now, if you input 5 volts, you don't say the battery now 4.2. This thing now has reduced 5 volts to what? To 4.2. Abi, you don't reduce them from 5 volts to what? 4.2. Even this board, it can take 9 volts and still bring it down to 4.2 to charge batteries that you have in parallel. Sure you get. But now, I want to charge my phone now. What does my phone, how many voltage does a phone need to charge? 5 volts. The battery you have here, no be 4.2 with full volts.
Yes.
Then, this board will now increase that 4.2 to 5 volts. So it's now boosting that voltage. But when you are charging the battery, this thing is bulking that voltage down to 4.2. And now this one now they call it fast charger. Why are they calling it fast charger? It's fast charger because you can input more than that 5 volts. You can input 9 volts here, you go peak. If you even put 12 volts here, you go peak. You go reduce them to 4.2. That's why someone say it needs fast charge. It means that it can charge when you are charging at a higher voltage service, it is faster. it is faster. When you are charging at a higher voltage, it is faster. If you are charging at a lower voltage, it's not fast. Okay, because let's assume now that this board can give us 5 volts 3 amps, and I say that voltage times current is what? Watt. This will now give us 15 watts. Abi 5 times 3 now 15. Then this board, if you do fast charge, if you give 9 volts 2 amps, which is equals to 18 Abi.
Yeah.
Then it can still give us 12 volts. I don't know if it's up to 2, but let's say 12 volts 1.5 amps, which is equal to what? 12 times 1. 12 times 1. 12 times 1.
12.
Yeah?
12.
12 times 1 is what?
12.
Then half of 12 is 0.5 times 12. Half of 12 is what?
6.
It's still 18 watts. So there are some people's phone, that thing that someone said that my phone can charge fast. If you put it here, if this thing now, but you will use the right cable. You know all this type C cord, you use the right one, so that this board now and your phone, they will communicate. If they communicate, it cannot enter that 9 volts. If they cannot communicate, now only 5 volts you go take the charge. Now why I say if you plug fast charger, you go take small time, you go come enter that 9 volts or 12 volts, depending on what your phone can take. There are some power bank that can take 12 volts. Before it takes 12 volts, it go communicate with the charger. Say, okay, I want to use 12 volts. You say, are you okay? You say, are you okay? Or yeah, let's enter 12 volts. They will just enter 12 volts. They will be happy. So now, I want to show you something here. So look at this charger, just in case you want to go and buy a charger now. They say, yeah, now output voltage now we look at. They say 5 volts 2 amps. They say 5 volts 2 amps. This charger now no be fast charger now e be. If you see fast charger, they will say 5 volts 2 amps, 9 volts, maybe 1 amp, 12 volts, something, meaning that this charger now, if he give you 5 volts, if he give you 9 volts, if he give you 12 volts, but this one now they just say 5 volts 2 amps. You already know the kind of phone you will use and try. If your phone they charge fast, you know go charge fast for you, unless you go and get their other version will be fast charger. You can believe them too, they have fast charger. Okay, so that is just it's about that one. So that is it about this bulk boost. That is by the way, sha. Then this one now is what? Bulk converter. This is what? Bulk converter. That is usually the way this one looks like. I don't want to open them now unless somebody will buy them then no open them. So this is bulk converter. And I said they use bulk for what?
For balance.
They use bulk for
If you hear bulk, know that it's to reduce something. So here you have input and you have what? Output. When you are using this bulk or even this one, stop that video and start it and start another one. So when you are using bulk,